So in this video we are going to be talking about moment or moment of force. We know that moment or moment of force is equivalent to force times distance, and we'll specifically be talking about the seesaw moment, as that confuses people the most for some reason. And the SI unit for moment are Newton meters, N being capital and M being small. So anyways, let's get on with the lesson. So we have two masses or two blocks or two objects sitting over here, and let's say that I have 40 newtons for this one and a force of X acting on for this one, and this we can say has a distance of we can see this has a distance of 0.5 meters and this has a distance of 0.8 meters, but it's not drawn to scale, so it's okay anyways. And it tells us to find X. Now, what do you think we will do? Now that's what I will explain today. So the first thing we always need to do when we get these types of any type of question that has something regarding a lever, whereas this is a lever, you use this method. So the force acting upon this, when this goes down, it's known as anti-clockwise. It's anti-clockwise. Yeah, the moments are anti-clockwise, and this is always clockwise. And the one thing we always estimate is that the clockwise moments are always equivalent to the anti-clockwise moment. So we say that clockwise moment is equivalent to anti-clockwise moment. So with that in mind, we can make an equation for this. So they tell us to find X, yeah? But some people will think we aren't given enough information, but we actually are. So we know that moments are equal to force times distance. Since we said clockwise moments are equal to anti-clockwise moments, we always say that this side is equivalent to this side. So whatever goes on here is equivalent to what goes on here. Even if it has different masses, different distances, different boxes, blah blah blah, it's always the same. That's what's always estimated. Yeah. So what we do is that we make an equation. So we want the moments of the blocks on each side. So for this side, it will be 40 times 0.5 because of force times distance. This being the force, I'll just do this. This being the force, this being the distance, is equal to, because clockwise moments are equal to anti-clockwise moments, both of these are the same, is equivalent to 0 to X times 0.8, whereas this is the force and this is the distance. And now we just solve for X. Yeah, that's literally it. So 40 times 0.5 is equivalent to 0.8x. This is because x times a number is that number x, yeah? And 40 times 0.5 is, let's just see, 40 times 0, 5 times 0 is 0, 5 times 4 is 20, 0 times 0 is 0, 0 times 4 is 0, then 0 is 2. Point, because of the one decimal because of the one decimal point, you get 20. So it's 20 is equal to 0.8x. 0.8x, yeah. And then because of algebra, we can just rephrase it. 0.x is equal to 20 and we can say x is equal to 20 over 0.8 because we are dividing 0.8 on both sides. And when you do the math, you get 25 newtons. And since math is cool, let's just do the math. Let me just cancel some things. So 20 times 0.8 is equivalent, you multiply both of it by 10 because of 1 dp or decimal point, you get 200 over 8. And when you do 8 divide by 200, let's just take it all the way here. 8 divided by 200, or 200 divided by 8 actually, sorry. You get 0, that is 2, 16, bam bam, 4, 0, 5, 40. You get 25 newtons. You get 25 newtons. So we actually solve for x. Sorry, no, that's too screwies. Let me use a different color. X is equal to 25 newtons. How cool is that? That's the answer. That's how cool it is. And that's how you go about it. That as the first example. Now let's move on to the second example. We wouldn't like to cancel my very hard work drawing. For this, let's say we have a force of 30 newtons and a distance of 1.8, another distance of 0.25 and 20 newtons. But here's the twist. Let me add another object. You guys may be wondering where. I'm not crazy, I promise you. Here. And let's say that the force acting upon it is x. Find x. Now what do you think? I'm sorry, we are not even done. And the distance over here is 0.3 meters. So what do you think that we will do? And last one. Sorry, this is actually 0.5, it's not 0.25. 0.5. So now what do you think we will do? If you can pause the video yourself and work it out, because I know that you guys are smart. So we are told to find x. This time I go green, I don't know why. So we know that moments are equal to force times distance, and clockwise moments is equal to anti-clockwise moments. So 30 times 1.8, so this 30 times 1.8 is equal to 0.5 times 0. But we are finding for x, so what we'll do, we'll have to add the distances first when we are finding for x. So basically 30 times 1.8 is equal to 20 times 0.5 plus x times 0.8, because the distance of this specific object, we are getting the moment of the net moments, that means the total moment of these two objects. So that means 0.5 plus 0.3 is equal to 0.8. So this is equal to 20 times 0.5, 20 times 0.5, and we're making this linear, so we add brackets. But you cannot, if you don't want to add brackets, you won't. Plus, because we are adding both of these, plus x times 0.8 because of the distance of this object from the pivot. Then we work it out. So 20 times 0.5 is equivalent to 10. So this is equivalent to 10 plus 0.8x. So 30 times 1.8 is equivalent to 10 plus 0.8x. And now 30 times 1.8, 30 times 1.8, you get that. I have to use a different place. 3 times 1.8 times 0 is 0. 8 times 3 is 24. 1 times 0 is 0. 1 times 3 is 3. That's 0, 4, 5. You get 54. So this is equivalent to 54 is equal to 10 plus 0.8x, and now it's just normal algebra. Let's cancel some sides because I don't have enough space, sadly. So now we get 50 is equivalent to 10 plus 0.8x. Then we get 50 minus 10 is equal to 0.8x. We get 40 is equal to 0.8x, and 0.8x is equal to 40. So x is equal to 40 divided by 0.8. Then we just do the division. So 40 divided by 0.8 is equal to 400 over 8. And when we do 50 times 8, you get 400. So the answer is 400, and x is equal to 400. So that's how you get the answer. Let me choose a different color. Again, red. X is equal to 400. That's how you get the answer. I hope you understood. If you didn't, I just hope you understood, and I would like to see you in the next video. Goodbye.